Hello, in this video we are going to practice to graph trigonometric function. Let's begin with the secant function. So we all know that secant theta is the reciprocal of cosine theta. So to graph the secant function, the first step, we have to graph the cosine theta first. And for this is the parent function, the period is 2 pi. I'm going to go ahead and just make the table for the positive angle only from 0 to 2 pi. So cosine of 0 will be 1. And then at the end, cosine of 2 pi is also 1. Okay. And cosine of pi will be negative 1. And cosine of half of pi be 0. And then 1/2 of pi or 3 pi over 2 also 0. So we'll go ahead and graph the cosine graph. So 0, 1, pi over 2, 0. We'll plot the point, pi negative 1, 3 pi over 2, 0. And 2 pi 1 will be here, but we run out of, the window is not big enough. So I'm going to go to the left-hand side. So again, cosine is even function. So it means that the y-axis will be the symmetry of the graph. So therefore, the points on the left and the right-hand side will have the same y value, opposite angle. So like for example, here pi over 2, 0, this will be negative pi over 2, 0. And pi negative 1. So that will be negative pi negative 1. 3 pi over 2, 0. So be negative 3 pi over 2 be 0. So this will be the point that will help us to graph the cosine. So now you can see right here that this is kind of more than one period. Okay. So the next step, now we want to graph the secant function. So I'm going to go ahead and just show you the graph. Okay, so you can see right here that the vertical asymptote is so when you already have kind of the point from the cosine, so where the cosine equals 0, that will be our vertical asymptote. So if I'm looking on the positive x or the positive angle theta, sorry, so you can see that. Now we do the same thing on the left hand side where the cosine is 0. That will be our vertical asymptote. Okay, next. Where the maximum of cosine, it becomes the local minimum for our secant. Now, the secant function doesn't have the amplitude because you can see right here that the graph doesn't have the y maximum, doesn't have the y minimum. Okay. And again, if you look at the next one, where y equals negative 1 is the minimum for our cosine. Now it becomes the maximum, become the local maximum for our secant. So there will be a big difference between the local and the absolute. Okay, so let's go ahead and describe the graph. So you can see right here that this graph, that the secant graph doesn't have amplitude. the periods would be the same as cosine would be 2 pi. And again, if you can see right here that we just graph the parent of cosine, the parent of cosine function, so there's no phase shift. Phase shift, it means when you shift the graph to the left or to the right. And there's no vertical shift, it means that when you shift the graph up or down. And no minimum, no maximum. For the vertical asymptotes, we only list 2. Here, there are 4 of them. So on this graph, so there'll be 4. So you can look at here, x equals 3 pi over 2, x equals pi over 2, x equals negative pi over 2, and x equals negative 3 pi over 2. Okay, let's move on to the next example. So let's look at this example. So this would be just the cosine function, and we only did it in example 1, so it'll be very easy. And again, you can see right here that our cosine function does have the absolute maximum is y equal 1. And it does have absolute minimum, which is y equal negative 1. So therefore, the function cosine does have amplitude is 1. The periods at which it is in number 1, the period of cosine function, the parent function be 2 pi. And again, the graph of this cosine function have no phase shift, no vertical shift, and the y minimum, the absolute y minimum is negative 1, and the absolute y maximum is 1, and cosine doesn't have vertical asymptote. Okay. Let's move on to the next example. This is the tangent function. I'm going to go ahead and share with you the graph first before we go back and go over this. Okay, by looking at the graph of tangent, we all can see that tangent does have vertical asymptote at negative pi over 2, positive pi over 2, and so on and so forth. But the periods of tangent will be pi. It means that the graph will be repeat the same pattern again for every pi. Okay. And tangent doesn't have amplitude. The graph of tangent doesn't have amplitude. Why? Because we don't have any absolute maximum or no absolute minimum. We don't. Okay. And there's no phase shift. There's no vertical shift. Now the next step, I'm going to go back and I'm going to go ahead and make a table of tangent so that you can see why we say that. So let's go ahead and make a table. So this is the input and the output will be tangent data. So let's look at tangent of negative pi over 2. So again, if you sketch your unit circle quick, so I'm going to have to look at the unit circle here. So this is 0 degree, or zero radian. Okay, and let me go with radian. So this is pi over 2, and this will be 0 radian, pi over 2 radian, pi radian, 3 pi over 2, and 2 pi radian. So to get positive angle, you go counterclockwise. So this is negative angle. So you are going to go clockwise. So that will give a negative. So this is 0. This will be negative pi over 2. And again, this is negative pi. And then negative 3 pi over 2. And then negative 2 pi. So tangent of negative pi over 2 will be the same thing as tangent of 3 pi over 2. And tangent of 3 pi over 2 will be undivided, or tangent of 90 degrees. So I'm going to make a quick note right here for us. So we say that tangent of negative pi over 2 is the same as tangent of the positive coterminal angle 3 pi over 2. And if we use our hand trick, it will be the same thing as tangent of the reference angle pi over 2 and tangent of pi over 2. Again, tangent is sine divided by cosine. Or if you use your hand trick, so I'm going to go ahead and draw the hand quick right here. So if you use the hand trick right here, so pi over 2 is 90 degrees, or your thumb to tangent will be the square root of below finger divided by the square root of above. So that therefore will be undivided because you divide by 0. So that's why we have the vertical asymptote. And next one, go ahead and look at negative pi over 4. So at negative pi over 4, so again, negative pi over 4 will be in quadrant number 4. Yeah, so tangent of negative pi over 4. Now, if you think about your reference angle, right, so this is the same thing as negative tangent of pi over 4 to be negative. And again, use your hand trick. So pi over 4 will be at the middle finger. So square root below finger divided by square root of above finger. So that gives us negative 1. So that will be the point right here. And then we do tangent of 0 will be 0. And then tangent of pi over 4 will give us 1. And tangent of pi over 2 will be undivided. Okay. So that's what we have the graph. Now you can look at the graph of tangent. The graph is increasing. Okay, so let's move on to the next one. Now we are going to graph the cosecant function. So this is the graph of cosecant function. First of all, the amplitude, the cosecant function doesn't have amplitude. The period is 2 pi, and let me explain to you why 2 pi now. We all know that cosecant is the reciprocal of sine. So think about your sine function. I'm just creating a table for the sine function. Okay. The sine function have the period is 2 pi. Okay. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi be 0. So one complete period of the sine graph, the graph will look like a curve, like the ocean wave. Okay. Next step, after you graph the sine function, where the sine function equals 0, that will be your vertical asymptote. So before we plot the vertical asymptote, I'm going to go ahead and plot the left-hand side for the sine function first. So again, sine is odd function. So the point 0, 0, 0 is the symmetry. So think about at pi over 2, we get 1. So since 0, 0 is the symmetry, then negative pi over 2 will be negative 1. So sine of negative pi over 2 will be negative 1. Sine of pi will be 0. Sine of negative pi will be 0. Again, the point 0, 0 is the symmetry. And then sine of 3 pi over 2 is negative 1. Then sine of negative 3 pi over 2 will be positive 1. So now the next step you're going to do is go back to the graph, and where the sine function equals 0, you will draw the vertical asymptote. So from the positive angle, then we have the asymptote at x equals 0 and x equals pi. Now I'm going to the negative angle. So that will be negative pi. Okay, next step. And then go back between the two asymptotes. Let's look at from 0 to pi. You can see we have y equal 1 is the absolute maximum for the sine function. Now it becomes the local max for the cosecant function. So you can see, and then let's look at here, for example, at 3 pi over 2, y equal negative 1 is the minimum for the sine function. Now it becomes the local maximum for the cosecant function. Okay, so now the next step, we see, so you can see right here that we say that the cosecant function doesn't have the amplitude, and the period is 2 pi, and this is the parent function, have no phase shift, no vertical shift, and again, for the cosecant function, we don't have the absolute mean or the absolute max, because you can see right here that the graph of cosecant, it will go to the infinity. And the vertical asymptotes, here we only list 2. We only say x equals 0 and x equals pi, because we only list 2, but of course there will be x equals negative pi here too. Okay, so let's move on to the next graph. So this is the cotangent function. So this is the graph of cotangent function. So again, cotangent function doesn't have amplitude. The period is pi, and because you can see right here. Let's just look at the vertical asymptote at x equals 0, cotangent will be undivided, and at x equals pi, cotangent will be undivided too. And so this is one period of cotangent. And then if we look at on the left hand side will be, this is the other period. So again, the graph just repeats itself for every period. Now you also can look from the table. So if we create a table for the cotangent function. So the cotangent of 0 will be undivided. And again, if you wonder why undivided, I'm going to have to just show you quick here. So from the unit circle, so this is 0. So cotangent of 0 radian. So you can use the unit circle or you can use the hand trick. So now if you use the unit circle at 0 degree, cotangent is cosine of 0 divided by sine of 0. So cosine of 0 is 1 and sine of 0 is 0, so that will be undivided. And if you want to use the hand trick, so this is a 0 degree. So cotangent of 0 of 0. So cotangent is the reciprocal of tangent if you think about it this way. So I'm going to put 1 over tangent of 0. Now tangent, so since we know tangent is the square root of below finger divided by the square root of above finger if you want to use the hand trick. And here, so that will be, so go ahead and when we divide fraction, we multiply by the reciprocal. So that will be square root of above finger divided by square root of below finger. So therefore, cotangent of 0 is the square root of above finger will be 4. So this will be the above finger. So square root of 4 divided by the square root of below. We have nothing below. So therefore square root of 0. So again it'll be undivided. So there are lots. Just show you there are 2 ways to do it here. Or actually there are 3. There are 2 ways to do it here. So it's up to you. Okay, so let's go back here. Now go ahead and look at the next one. How about at pi over 4? So cotangent of pi over 4 will be 1. And cotangent of pi over 2 will be 0. Cotangent of 3 pi over 4 be -1. And lastly, cotangent of pi will be undivided. So where the function is undivided, that will be your vertical asymptote. Okay, let's move on to the next example. Okay, so let's look at example 6. So this is just a very simple, it's just a sine function. So we can go, so this is the graph of the sine function. We all can see that the graph does have the absolute maximum is 1 and the absolute minimum is -1. So therefore, the sine function does have amplitude is 1 and the period for the sine function will be 2 pi. And in this case, this is the parent function, so be no phase shift, no vertical shift, and it does have the y minimum, which is the absolute minimum, is -1, and the y maximum is 1. Also, sine function doesn't have vertical asymptotes. Okay, now let's go ahead and graph 3 more functions, but this time we are going to take our parent function and we do the transformation. So let's look at the next example. Okay, so this is the cotangent function. So y equals 4 times cotangent of x. So the first thing, if you have notice that this is not the parent function because we do have a 4, our leading coefficient, which is a 4 right in front of cotangent of theta. Okay, so again, for the cotangent function, it doesn't have amplitude, and the period is pi. Why? So think about if we look at our parent function. So for our parent function, the period is pi. So now for this new function, y equal 4 cotangent of x. So again, to find the period, we will take pi divided by the number right in front of our theta. So if I make a quick note for that, if we have a new function, like I'm going to just say that will be a new function, y equal a cotangent of b times theta. Okay. So to find the period of our new function, we just take pi divided by the coefficient or the number right in front of theta. So in this case, the number right in front of theta is, we don't see nothing, so it will be the invisible number 1 here. So that's why the period will be pi. So again, why we say that they have no phase shift and they have no vertical shift, because you think about here, if the function have any phase shift, then you will see our variable, our input will be subtract or add a number. Okay, so this will be for the phase shift. And next, for the vertical shift, then at the end, the whole function will add or subtract to a number. So this will be vertical shift. So in this case, that's why we say that this function have no phase shift and no vertical shift. And also the tangent, since it have no amplitude, so it means that it will not have the absolute minimum or the absolute maximum. And let's move on to the vertical asymptote. So from the graph, we can see right here that the vertical asymptote is x equal 0, x equal pi for the positive input, and for the negative input will be x equal negative pi. So where are they come from? So you can think about, I'm going to go ahead and make a table quick for us so we can see. Let's make a table. So we make the table. So this would be for cotangent theta. Now let's think about our parent function first. Cotangent of 0 is undefined, so it doesn't. So 4 times undefined is still undivided. Okay. Cotangent of pi over 2 will be 0. So therefore 4 times 0 is still 0. And then cotangent of pi will be undivided. So the same thing with 4 times undivided would still be undivided. Let's go here between 0 and pi over 2 will be pi over 4. So we know that cotangent of pi over 4 is 1. So now will be 4 times 1. So that will be 4. So you see the point right here. And next, cotangent of 3 pi over 4 is -1. So 4 times -1 is -4. So the graph of cotangent function is a decreasing graph. So you can see that the graph at x increase, y will be decreased. And then that describes, so for the vertical asymptotes, we only list two because we look at the positive x equals 0, x equals pi, or you also can say x equals -pi because we just look at from the right hand side. And then for the transformations, so in this case, we start with the parent function cotangent, and we do a vertical stretch by a factor of 4. So if you can see right here, if you look at the output, each one of the value in the output will be multiplied by 4. Okay, so now let's move on to the next example. This is the cosecant function again, but if you can see right here that compare with our parent function, the period will not be 2 pi, okay, because you can see right here that since the number or the coefficient in front of theta is 1/3. Okay. So right here the first step is that we all know that only sine and cosine have amplitude. The rest of the function they will not have amplitude. So therefore, cosecant, in this case, this function cosecant doesn't have amplitude. Now the period is 6 pi y. Okay, so think about what we just say right here. So if we give you the function y equal a cosecant b times theta. So right here, to find the period for cosecant, you will take the period for the parent function 2 pi. In this case, because there is a coefficient b, so 2 pi divided by b. So if I have y equal cosecant of 1/3 times theta, so my b is 1/3. I'm going to go ahead and rewrite this at 1/3 here. So therefore, the period will be 2 pi divided by 1/3. Now, when we divide fraction, the same thing as we multiply by the reciprocal. So we multiply by 3/1. So that will give us 6 pi. Okay, next step, we say that this given function that the graph, the graph doesn't have any phase shift. And again, we just review from the previous example, it doesn't have phase shift because you don't see nothing right here. So again, when they see it, that will be your phase shift. Okay. And next, it does not have any vertical shift. And again, for the vertical asymptote, by looking at the graph, we all can see that the vertical asymptote is x equals 0, x equals 3 pi on the right side. If you look at the left side, be negative x equals -3 pi. Now, where are they come from? So if you're thinking, if you are Okay. If you're thinking about, let me just create the table quick so that you can see that. Cosecant theta divided by 3. Okay. So cosecant of 0. So again, just keep in mind that cosecant is the reciprocal of sine. Okay. Sine of 0 is 0. Okay. Cosecant of 0 is 1 divided by 0 will be undivided. So now we take 0 divided by 3 is still 0. So therefore it's still undivided. So that's why we have a vertical asymptote here. And again, the period is 6 pi. So I'm just looking at half of the periods here first. So I'm looking at so 3 pi here. So 3 if we substitute theta for 3 pi divided by 3 become cosecant of, so here I'm going to write the cosecant of 3 pi divided by 3. So that will give us cosecant of pi. So cosecant of pi, it again will be undivided. So therefore, that will be our vertical asymptote. So now I'm going to go ahead and look at half of this. So half of 2 pi will be 3 pi over 2. So now if we want to, so now we will have to substitute our theta for 3 pi over 2. So therefore, I'm going to go ahead and write it right here. We have cosecant of 3 pi over 2 divided by 3. So when we divide, it means that we will multiply by the reciprocal. So we 3 pi over 2 times 1/3. So cancel the 3. So that will give us cosecant of pi over 2. So cosecant of pi over 2. Now we know that sine of pi over 2 is 1. So therefore, cosecant of pi over 2 will be 1. So you can see the point right here. Okay, so I hope that it will make more sense for us. So again, you do exactly the same thing. So you keep going. Okay. Okay. So let's do one last example. In this case, we will have the phase shift. Okay, so that this is the sine graph, and again you can see right here that the amplitude is 1. Now, without looking at the graph from the equation, you also can tell the amplitude right away. So the amplitude is the absolute value of your leading coefficient, the number right in front of sine right here. So if I can write a quick equation, it will have y equal a sine b x minus c plus d. So, okay. So amplitude is the absolute value of a. So therefore, the amplitude is 1. The period will be 2 pi divided. So period is 2 pi divided by b, absolute value of b. So in this case, our b is 1, so therefore the period is 2 pi. And we do have a phase shift. So in this case, we shift it to the right. So C, that's it, our phase shift. And if C is positive, then we shift to the right. So in this case, we shift to the right by pi over 4. And we don't have vertical shift. So D will be our vertical shift. So no vertical shift. And vertical asymptote B naught, we also have the absolute maximum is 1. And the absolute minimum is -1. Okay, you can see that. And the transformation. So we will take our parent function. We start with our parent function, sine theta, and then we take our parent function, we shift or we translate it to the right by pi over 4. So you can see that if I'm going to go ahead and get the parent graph so that you can see. So the parent graph is start right here. Okay. 0, 0, pi by 2, 1, pi 0, 3 pi 2. Okay. And then on the right hand side, okay. Pi by 2, -1, and then pi 0, 3 pi over 2, 1. So this will be, so you can see right here that the one in black, those are the graph of our parent function sine theta. So now you just take that and then you shift it to the right. So every point will shift to the right by pi over 4. Okay, thank you so much for watching. Goodbye.